Hello again, everybody. Welcome back to CCCS214, Object-Oriented Programming 2. And today we continue uh, a study of binary I/O in Java. So this is kind of where we left off. Last time we were looking at the FileInputStream class in Java. Today we continue and we look at the the filter input stream and two of its subclasses, the DataInputStream and BufferedInputStream classes. And similarly on the output side, we're going to look at the FilterOutputStream class, which has as its subclasses the BufferedOutputStream and DataOutputStream classes. So first looking at the DataInputStream class. So as you can see from the previous UML class diagram, DataInputStream is a subclass of FilterInputStream, which is a subclass of the abstract InputStream class. Now, the DataInputStream class itself, as you can see, has only a constructor method over here. But it has obviously we do have lots of other methods for this class, but those are not inherited from the input stream or filter input stream classes, but are come from an interface that it implements, and that interface was not depicted in this UML class diagram we looked at earlier. So the interface that it implements is the data input interface, and in this second UML class diagram, the reason we can tell that data input is not just an abstract class but an interface is that if you pay close attention, this line connecting the data input stream class to this data input something interface over here is dotted, so that's how we can immediately tell that this over here is an interface. And take a look at the different methods that it offers. We have read boolean, read byte, read character, read float, read double, read int, read long, read short, read line, which is like an entire line of characters, and read UTF if the line of characters that you're reading, if that is in UTF format. And correspondingly to the data input stream class, we also have the data output stream class, again, which is a subclass of filter output stream, which is a subclass of the abstract output stream class. Again, the data output stream class itself only has a constructor method over here, and I'll come back to talking about the constructors of both this class and the data input stream class. And as you can see, almost all of the useful methods that we're interested in come from an interface, the data output interface that it implements. And you can see that all of the methods over here are basically correspond to the methods that we saw for the data input stream class, with one notable exception. As you can see over here, we had a read char or read character method, which returned a single character. For the data, and the data output interface has one additional method that we want to pay attention to. So we have the write character, write char method, but in addition to that, we also have a write chars, so plural of characters, so write characters method. The difference between them is this: write character writes a single character to file, write characters can write, takes a string as argument and can write more than a single character to the file at a time. And the remaining methods are basically write methods that correspond to the read methods of the data input interface. So as you can see, we have separate dedicated methods for reading and writing UTF, Unicode, Unicode character, Unicode text, and I talked about this a little bit in class. Unicode characters are bigger than ASCII characters. ASCII characters are 8 bits in size. Unicode characters are 16 bits, typically 16 bits in size, but there's also some other standards that take that up to from 2 to 3 bytes, meaning up to 24 bits. So, like I said, I'll come back to talk about the constructor of the data input and data output stream classes. And as you will see over here, it is mandatory that you provide an argument. And interestingly, that argument is of type input stream. So let me just jump back. So input stream, that's this abstract class at the very top over here. And just like that for the data output stream class that we're looking at right now, that requires its constructor also requires an argument of type output stream. So here's an example of how the data input stream and data output stream constructors work in action. So let's say you want to open create an object of type data input stream, calling it, let's say we call it in file. You construct that just like you would any other object using the new keyword and calling the constructor for data input stream. But inside the constructor as argument, we have to pass we pass it a file input stream object in this case. So basically we have to provide a file handle. So actually not a file handle, we have to provide an object of type file input stream, and we do that over here. So we're basically creating an object inside and passing that, creating an object right here inside the argument for data input stream, for the data input stream constructor, and the same thing for the output, data output stream object. So let me show you an example that's called test data stream, some sample code. So we'll walk you through that. We import classes from the java.io library, and so the test class is going to be just a main method called test data stream with a main method, and we're dealing with data input stream and data output stream objects which can throw IO exceptions, so that is acknowledged here for the main method. And this is what I was talking about. So we are going to create a file called temp.dat, and name is passed to the constructor of FileOutputStream. We're going to write to this file first, and I want to open this as I want to write. I don't want to write individual bytes to this file. Instead, I want to use the primitive data types that I have available in Java. And yeah, I should have said that a little earlier. So that's basically the key difference between the data input stream and the data output stream classes, and the file input stream and file output stream classes that we used in the previous lecture. FileInputStream, FileOutputStream deal only in bytes. You can only read a byte or write a byte. But what the DataInputStream and DataOutputStream classes allow you to do is they let you read or write data in sizes other than 8 bits um, or in formats other than bytes. You can read a character, read a floating point number, double, integer, long, short, even strings of characters, both ASCII and Unicode. And same thing for when it comes to writing data to a file. So this is obviously going to be much more convenient. And so I'm just jump back to our code. So just like in the slide, I'm creating an object called output of type of class DataOutputStream, and then I'm going to write some records, any information really to that file, and I'm going to write the format of the file is going to be basically a string containing a single name, and I'm going to use the write UTF method for that. And after that, I'm going to put a number after that. Number, I don't know, could be a score or something. So that number can also be a fraction. So I'm going to use the write double method to do that. And I'm going to do that for 3 people over here: John, Jim, and George. And when I'm done, I'm going to close the file using the close method, which is familiar from last lecture for the FileInputStream and FileOutputStream classes. And then I'm going to open this file for reading using a DataInputStream object that I'm calling input. And again, you can see that in the argument of the constructor of DataInputStream, I have to provide a FileInputStream object, and in its argument I'm providing the file name again, temp.dat, the one that I'm trying to read from. Now, once I have that, once I have object input created, I can then simply call inputs read UTF method, because in order to do this right, I have to know in which format the information, the data, has been written to the file. So I know that the format of the file is such that I have a string followed by a double, another string followed by a double, and another string followed by a double. So I'm going to call read UTF followed by read double, and I'm going to do that 3 times, and I'm going to print out the string and double pair on one line, separated by a space. So let me just run this. Fairly straightforward. And there you go. So I wrote this data to the FileOutputStream, the DataOutputStream object, which landed in this file temp.dat. Just check that out. Test data stream, and there's that file temp.dat. And if I open it, I won't be able to see much. See, because the string characters are UTF characters, looks a little messed up. Okay. Now, come back over here. I could make a slight improvement to this, because over here I had to know that there are basically 3 of these record pairs in the file, and so I called read UTF and read double 3 times each. Now, might be the case that I don't know how many records are in the file. So in that case, what I could do, I could use a loop. Okay. And the question now is, how do I know whether to attempt reading a UTF string and a double, and when to stop? And it's actually another method we can use. Input dot available. Okay. So the available method tells me how many bytes are left in the file from the read pointer location onwards, and when that is, as long as that, as I have any bytes to read, I'll continue going through, I'll continue reading from the file and writing the output. So I can, slightly more elegant way, do the same thing like this. So now it won't, now at least for this part of the program, it won't matter how many records I have in the file. As you can see, I can now write, take this, I can add a fourth record over here to the Z's and give him a score of 110.30, and now I don't have to modify the reading part. It'll work as is. Okay. So that's how you can use the available method that these classes give you. Okay. That's basically what is said on the next slide. So you can check for whether you have reached the end of a file by calling the available method to check if there's any data left in the file or not. If there's no data left, the available method will return the value 0 to you. Okay. Now, last week you did an assignment in which I asked you to copy a fairly large file of about 35 MBs or so using the read and write methods of the FileInputStream class and FileOutputStream class. And you discovered that it was a very slow process. Copying about 35 MBs took about, on some people's computers, took about 4 or 5 minutes. Now there's a faster way of doing this, of course, because you copy files on computers all the time, and you know it doesn't take that long to copy a file that's just 35 MBs these days. We can do the same using, we can significantly speed up the task of copying data from one place to another using the BufferedInputStream, reading or writing actually data from to or from files using the BufferedInputStream and BufferedOutputStream classes. And so what we're going to do is we're going to write another program that does the same thing our programming task of last week did, but it's going to do it much more efficiently. So key differences are that when you open BufferedInputStream versus FileInputStream, is that Java creates a buffer for you to read from instead of when you call the read method for the FileInputStream class, Java goes to disk and reads that one byte that you need for you. If you use a BufferedInputStream class, on the other hand, there will be a buffer created in memory, and a whole chunk of that file will be put into that buffer. And when you ask for a read, uh, instead of fetching it from the disk, which is orders of magnitude slower, that data will be read from the buffer. So basically you'll have a copy of part of the data that's in the file in a location on your computer that is faster to access. The same thing goes for the output stream, the BufferedOutputStream class. There are also some other differences in some methods that buffered input and buffered output support, FileInputStream and FileOutputStream support regarding marking locations, resetting those locations, or skipping ahead. But for the moment, we're not interested in those. So this is how you call the constructors for BufferedInputStream and BufferedOutputStream. Works the same way as for the DataInputStream and DataOutputStream classes that we just used. In addition, there's another overloaded version of the constructor in which we can also specify the size of the buffer that is created to keep copy of the file data in. So going to create, or actually look at a program called copy, which does the same thing, copies contents of one file into another file of a different name that you can specify. So just jump over here. This is the copy program using streams, buffered input and buffered output streams. It'll work the same way as the program that you did in your last programming task 3.1. This program is going to accept two arguments from the command line. The first one, the source file, contains that contains the data, and the second argument is going to be the name of the name that you're going to give to the copied file, the duplicate file. So first of all, it's a good idea to check before doing anything else if you expect two arguments or any number of arguments from the command line, to check if you actually have received as many arguments as you need. So the first thing that's happening over here is we're checking if args.length, the number of elements in args, the array of strings, if that is equal to 2. If it's anything other than 2, it means somebody made an incorrect entry of some kind, and we simply exit the program. Second, so if the number of arguments is correct, you proceed. args0 should be the source file containing the data. Create a source file over here, and you check over here if that file actually, if a file with that name actually exists. That's what's happening over here. If it does, fine. If not, again, you exit. The second argument should be, or is, the name that you're going to give to the file, to the duplicate file. And if there's already a file in the system with that name, that's a problem. So you check if the name of that file already exists. If it does, problem, and you exit. So opposite conditions. Over here you check if the input file does not exist, that's a problem. If the name of the output file already exists, that is a problem. Okay, so after you have checked if your arguments are valid, the number of arguments provided to you, to your program, are valid, come to the creation of object of class BufferedInputStream, solid input, and in the argument you can provide a FileInputStream object, and we give it the name of argument of arg1 source file, create another object, BufferedOutputStream object called output, and do the same thing in the its constructor. Okay, so as you can see, we're still going to read data over here byte by byte, create an integer r that is going to contain each, to store each byte between copying and writing, reading and writing it. We're also going to keep track of how many bytes have been copied, just a fun statistic. And we use the read method on the BufferedInputStream object input. And as long as the return value is not -1, so the read method still works the same way, as long as the return value is not -1, we write the value of r as a byte with the write method to the output object. And we increment the value of number of bytes copied by 1, for keeping track of how many bytes we've written. When we're done, we close both input and output files, source and target files, and just to make use of number of bytes copied, we print out its value to say how many bytes were actually copied from one file into the other. Now this program will need some command line arguments, so I'm going to, what I've done is, let's go over here, copy. I've placed the joker.mp4 file in the project, NetBeans project folder for this program copy. So I'm going to copy this file about, as you can see, it's 35-36 MBs in size, and as you remember from last time, it took quite a while. So let's go over here, change the project configurations, provide some arguments over here, joker.mp4, that's my source file. I'm going to call the other one joker copy2.mp4. Okay, I'm going to run that and pay attention to how much time it takes. And done. And this, so building it and running it and copying those 36 MBs took about 2 seconds. Now contrast that to the 4 or 5 minutes it was taking us last week.